Hi, everybody. Today we are going to do Unit 8, Day 3. Please notice that I'm not starting with the first page of Day 3. Instead, I've skipped to the last page in your packet so we can go ahead and knock this out. So, we've already talked about degrees and radians, and we're going to fill those in. But first, let's talk about the coordinates of each of these. So remember that this Cartesian plane has 0, 0 as our origin. So we're going to label where all these points would be located on a normal coordinate plane. So remember that a unit circle is named a unit circle because it has a radius of 1 unit. So we're going to start with what's called the quadrantal angles. And that's a big fancy name for saying the 4 angles that fall on each of the quadrants. So let's start with this angle right here. This angle is 0 degrees, and we're going to label the key point. Since this has a radius of 1, our radius equals 1, this key point is going to be 1, 0. By the way, our quadrantal angles are 0, aka 360 degrees, 90 degrees, 180 degrees, and 270 degrees. Whoops. So those are the 4 quadrants, so we're going to label those first. So we've got 1, 0. Now this guy is tall. We're going up on the y-axis, so this will be 0, 1. This time we're going back, -1, 0. And then down here, we're going to have 0, -1. So it looks like we have 12 more key points to label, and we do, but the good news is that if you know these 3 in the top right, then you know all the others. Remember how we talked about reference angles? This is one way that reference angles benefit us. So here are the steps to finding these key coordinates. Step 1, we're going to put everything over 2. Step 2, we're going to count to 3. We're going to count 1, 2, 3. 1, 2, 3. And then step 3, we're going to put all of our numerators under a radical. So let's go. First, we're going to take everything and put it over 2. The second thing we're going to do is count to 3. So we're going to start by going down 1, 2, 3, and then back up 1, 2, 3. And then the third thing we're going to do is put all of our numerators under a radical. Now we already know that the square root of 1 is just 1, so we're going to leave our 1's alone, but we're going to put our 2's and 3's under some radicals. So if you can put everything over 2, count 1, 2, 3, 1, 2, 3, and put all your numerators under radicals, you are going to be good to go to label these 3 key points. Now remember reference angles? Reference angles tell us that all of our angles can reflect back to a positive angle in the first quadrant. So this is a reference angle. We know that this angle is 30 degrees, aka pi over 6 radians. There are some other angles that have this as their reference angle, specifically this angle, and this angle. These all have a reference angle of 30 degrees. Sometimes my students like to refer to these as bow tie angles because you can see they make a little bow tie if you've got a little stick figure. Put a little bow tie on them. So all of these angles that make a bow tie together are all have the same reference angle of 30 degrees or pi over 6. So the good news is because they share a reference angle, they're going to share key coordinates. So if you know that 30 degrees has it, you can copy those key coordinates into the other 3 spots. Now you might be noticing, wait a second, they can't all be exactly the same. There's something missing. And you're right, we're missing signs. So there's one little thing that we need to account for, and that's signs. Here, we're going in the negative x direction, so our points are going to be negative, positive. Down here, we're going in the negative x direction and the negative y direction, so our points here are going to be negative, negative. And then finally over here, we're going in the positive x direction, but the negative y direction, so our points are going to be positive, negative. So let's adjust our points slightly to make sure they have the right signs. So when you put the signs, make sure that they're outside of the radical. We don't put them inside the radical, otherwise we'd start messing with imaginary numbers. Remember, the square root of a negative number is imaginary. We're not trying to deal with that. So just put your negatives outside of your radicals. So here, both of these are negative, and then over here, just your y coordinate is negative. So now that we know we can use our reference angles and we know our signs, we can label the rest. So let's do that now. So here we've got this is a reference angle. We know that this is 45 degrees, aka pi over 4. And there are 3 other angles that have this as their reference angle. This guy, and this guy all refer back to 45 degrees or pi over 4 radians. So now we can copy those x and y coordinates. So root 2 over 2, root 2 over 2, oops. Root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. And now the only thing we have left to do is make sure our signs are where we need them. So a negative here, we need a negative on both of these, and we need a negative on our y. And then we're going to do this one more time with our final reference angle. We're going to use this guy right here. So we know that this is 60 degrees, aka pi over 3. So again, we've got this guy, and this guy all refer back to 60 degrees, aka pi over 3. So we're going to use the same coordinate there. We're going to have 1/2 root 3 over 2, 1/2 root 3 over 2, and 1/2 and root 3 over 2. And then finally, we're going to make sure our signs are correct. So here, negative x, down here, negative x and a negative y, and then down here, negative y. And now suddenly we have all of the coordinates of our unit circle filled in, and we only had to memorize these guys and then appropriately reflect them into each of the other 3 quadrants. So now I'm going to give you a second to fill in the rest of your degrees and the rest of your radians, because when you have your group quiz, it's going to be really nice to have these in all the same location instead of having to flip around. So I'll do that with you as well. And then we'll move on to the last piece. All right, so there is your completely filled in unit circle. Okay, so how do we use the unit circle to quickly evaluate cosine of an angle or sine of an angle? So this requires you to think back for a second when we were doing our triangle trig earlier this year. If we have a triangle, and this time we know that since this is on a circle, what an awful circle, with a radius of 1, that hypotenuse is always going to be 1 no matter what. So this is going to be our opposite, this is going to be our adjacent. If we were to find the cosine of an angle, remember cosine of an angle is adjacent over hypotenuse. In this case, since our hypotenuse is always 1, the cosine of our angle is always going to be the adjacent side. Now, if we think about where that is on our triangles up here, if I were to make this into a triangle, this would be my adjacent side right here. That is the x value. So the adjacent side is always the x value. So to quickly find the cosine of an angle, the cosine of an angle can quickly be found on the unit circle by using our x output. Similarly, sine of theta rather, is equal to opposite over hypotenuse. And since our hypotenuse is 1, it's just going to be opposite. So how do we find that? Well, we look at how tall the triangle is. So if we want to know how tall the triangle is, we're looking at our opposite side here. We're looking at our y value. So the big thing I want you to take away from this, even if you're like, I don't remember any of this, Miss Gamlin, that's totally fine. I just want you to realize that cosine of theta is your x output and sine of theta is going to be your y output. So let's evaluate some of these. Let's start with sine of 120 degrees. That means we're going to look for our y output at 120 degrees. So you'll go up to your unit circle, you'll find 120 degrees, and then you'll look at your y output right there, and it's going to be root 3 over 2. And so our answer is going to be root 3 over 2. So this next one, 225, cosine, we'll go find 225. Cosine is the x, so that's going to be negative root 2 over 2. So this is simple as finding the outputs, negative root 2 over 2. Sine of pi over 6, this time it's radians, but that doesn't scare us. That just means we are going to look at pi over 6, and sine is our y value, so 1/2. Cosine of 7 pi over 4 is our x output at 7 pi over 4. That's going to be root 2 over 2. And then 405 degrees. You might be like, whoa, 405 isn't on there. But the good news is we know that 405 would have another terminal ray. We can find where 405 would land if we were to go around the circle in reverse. So think driving backward in Mario Kart, we're going to go a whole lap in reverse. So we're going to subtract a circle. So 405 minus 360, well, that's just 45 degrees. They're the same thing. So if we go up and find 45 degrees and we're finding the sine, that's going to be root 2 over 2. So a couple things when you do your classwork, first of all, pretty please change numbers 8, 9, and 10 to 7 pi over 4. I believe your practice says 5 pi over 4. That's because I already printed it before I made the change, and so you won't get the key, or you won't get the answers right on the key if you don't make that change. A few other things. I just wanted to jog your memory in case you forgot. It asks you to rewrite tangent, cotangent, secant, and cosecant in terms of only sine and cosine. So I just wanted to remind you of those real quick, because if I wasn't there to remind you, I don't want that being what makes you get stuck. Okay. And then the very last thing is you are going to see, sometimes you'll see like sine of, I don't know, negative 150 degrees. That means that you're going to have to go backward on the unit circle. So remember, negative angles go down. You are going to look at negative 150. And if you go up on your unit circle, you're going to see that's in the same position as 210. So if you're doing negative on your unit circle, you're actually going to be looking at a different positive angle. So sine of that would be negative 1/2. So just be careful if you're going negative, you'll end up landing on a different positive angle, and that's okay. And then finally, if you're doing something like, let me find a good one. If you're doing something like cosine of 225 degrees, or sorry, let's do cosecant of 225 degrees. I can't write. There we go. Cosecant of 225 degrees. Cosecant is the same thing as 1 over sine, so that's going to be 1 over sine of 225 degrees. So if we go and find sine of 225 degrees, that's negative root 2 over 2. So you're going to have 1 over negative root 2 over 2. It is okay to leave it like this. It's also okay to remember keep change flip. So keep your 1, multiply by 2 over negative root 2, and you'll get to negative 2 over root 2. And it's okay to put it like this. It's okay to put it like this. You can even rationalize the denominator, multiply by root 2 over root 2, and you'll end up with negative 2 over root 2 over 2, which is just negative root 2. So what I'm getting at is there's lots of different ways to say the same thing for some of these. I'm trying to put as many as possible on your key. So don't worry if you end up with this and you're like, I don't know how to go any further. It's okay to just stop with this.